Hello and welcome to lesson 13.1 Color Wheel, CS112 Computational Thinking for Dual Credit. This is made for the University of Idaho. Today we do start off with a warm-up. Our warm-up today is this information. Go ahead and fill this into your own processing program. Once you do that, provide a response to these questions. This should be what you get when you type that in. There you go. If you need more time, feel free to pause this. We will be moving on. So far, we've drawn a lot of lines and shapes, and today we're going to start using some trigonometry to draw lines at certain angles. In the end, we're going to be writing a program that creates a color wheel using the angle and HSB, which you'll remember is hue, saturation, and brightness. So a specific color mode that exists inside of NetLoad or inside of processing. So this is what we should have been able to get from our warm-up. Some things we should know and some different angles we should know is that an angle is created by two different rays that intersect at a vertex. Rays are where two things that start at a location and go out. In this case, we call these angles, or sides of an angle. Many of you may have learned a strange kind of word type thing called SOHCAHTOA. To remember the right triangle ratios of sine of an angle is the opposite over the hypotenuse. The cosine of an angle is the adjacent over the hypotenuse, and the tangent is the opposite over adjacent. If you don't know this little trick, SOH is so, CAH is ka, and TOA is oa. SOHCAHTOA. Additionally, something that we need to know about is using polar coordinates. Polar coordinates are extremely helpful, especially when we start talking about programming. Reason why is we start actually talking about the radius and theta, which is that angle. So you'll see right here, this is our radius, theta being our angle. So we're actually kind of talking specifically about the hypotenuse. There's a couple little tricks to help us learn how to go from polar to Cartesian, and really kind of more the mathematical side of it, if you will. So what we can do is we multiply both sides by r, and we're actually able to start getting our correct answers. If you don't know your radians and degrees charts, take some time, maybe find one, copy it out, so then you're kind of more familiar with how this works. What you'll notice, though, is that this is opposite from kind of probably what you were taught. The reason why that I say is opposite is 90 is actually going down, whereas 270 is going up. And this is because in processing, you remember also in processing that we kind of are upside down with our y values, and that really plays into this. The pi symbol doesn't necessarily exist inside of processing, so we actually use some capital letters pi. There's also other equivalent expressions that we can use, things that you might need from this radians degrees chart if we're trying to put these into our like pi ratios. One thing to note is that radians need to be in float. The reason for that is if you think of pi, it's that 3.14 continuing number that we still don't really know the end to. So in processing, angles are assumed to be in radians. So if we try both of these types of code, let's delete everything that we made. So let's draw a line from 0, 0. We're going to do 100 times the cosine of pi divided by 4. You'll notice pi is in that green kind of color right there. And 100 times sine of pi divided by 4. Oops, missed this. So if you run this, alright, we get this. Now, if for some reason we don't know um, the um, the radians, there's actually a way of changing a number into radians. And the way that we do that is like this. We say, okay, I want the cosine of, and let's say we want 45 degrees. So I can actually do radians, 45, double bracket there because we have to finish radians and we have to finish cosine. Then we can do the same thing here, 100 times the sine of radians, 45, double bracket. Actually, triple bracket on this one because we have to finish the radians, then we have to finish the sine, then we have to finish the line. And it's exactly the same. Let's make another one. Let's do a float. And we're going to call this center of x. I bet you can guess what that is. We'll make this the width divided by 2. Let's make another float. Center y. Again, I bet you can figure out what that one is, or where we're going to use that. Let's make an integer called r. We'll set it equal to 50 to start with. And let's make a line that starts at the center of x and the center, lowercase, center of y. And let's have it go from the center of x plus r times the cosine of radians 0 and center, oops, I didn't finish this off, the center of y plus r times the sine of radians 0. Finish that off. I kind of sometimes like those to be together. Let's see what that makes. Seems like a lot of typing to just kind of do something straight across, right? However, you can kind of start to see how this might be helpful of saying, hey, I wanted to draw from the circle, the middle. And let's kind of see what happens if we don't. What happens if I delete this? You'll notice I go straight up. So if I add those back in, this is some Control Z work right there, not some magic. I'm actually able to start at the center and go out to the right hand side. Alright. Now on this, I actually kind of mentioned it, is that we want to start modifying the code. And let's make it start making a little more dynamic, a little more kind of fun and interesting to work with. So let's make it an integer called angle. And this angle is going to be whatever we want it to set it to be. But let's start off with 0. And instead of saying 0, let's go and say angle. And if I hit play, okay, we're still there. Now let's try another one. Let's do 90. Ooh, not 980, 90. Straight down. Alright, let's try another one. Let's try 180. This should hopefully go off to the left. And then if I say 270, hopefully this points straight up. And then I can start playing with it. I can say, okay, 45. Oh, hey, look at that. Alright, let's try changing this up just a little bit more. Let's actually copy this. So Control C if you don't know the copy command. Let's go down a couple lines just so it's a little easier to see. Now, one thing that we're going to see is right here, and down here it says duplicate local variable angle. It means that we're starting a variable called angle twice. So it's kind of going like, whoa, wait, what? No. So let's change this. So let's make this, we could leave this number the same, 75. We can run it, and look at that, we got 2 lines. Let's make it a little more interesting. Let's change the colors on these. So if I go, let's make this stroke. Let's make this one green. So RGB, red, green, blue. So red is 0, 255 is green, 0 is blue. I run this. We can see right here that we actually have 2 things going. Now, one thing that we don't have happening right here is a draw function. And I've been asked this before of whenever we're coding this kind of me in demonstration, I don't write it in a setup and draw type thing. And so without telling it setup and draw, it's going to run all of this once. However, if I were to run a draw, let's say let's put this all inside of a draw. Draw. If I put this inside of a draw, they both turn green. Take a moment and think why you think that happens. Hopefully you kind of realized void draw runs multiple times. And so for a brief second, and it's like almost so fast that we don't even notice it, this first line actually is black. However, because it comes back through and runs this draw again, it tells it, oh, we never changed the color back. So if I want to change the color, I can tell it to. And I can do it either before or after the angle, but I kind of have a pattern going down here already, so let's do this here. So let's say the stroke needs to be, let's make it red, 255, 0, 0. I run that. Now, each time it actually jumps back and forth. It says, okay, we're set this to red, set it to green, set it to red, set it to green. So your assignment is going to create a color wheel where the rays are drawn from the center of the canvas to the radius of your choice. Each line should go from the center to a location on the outside. And we kind of already talked about this, and it's actually shown on your screen as well, of how to approach that. The lines should be drawn for the 360 degrees of the circle and increment by a color each time. Use the color mode HSB to do this. Remember, by default, it's RGB, so you need to go and tell it how to be HSB. Choose a stroke weight and kind of make it look nice. Here's the kind of tricky part that I've kind of had is once you have that functioning, and that's the really big thing with coding, is have it function first before you start adding on new things. Once it's actually there, then you can start messing with stuff. So once you have that color wheel working, add code to have that wheel rotate when the mouse is pressed. Here's a hint. Use a variable called rotate to increase your angle each time through the draw. Be sure to comment on all sections of your code and submit the program as a zipped folder. If you forgot how to put that as a zip folder, you can check out the video how to submit processing as a zip folder. That's everything for today, and as always, happy coding.